Hello and welcome to Math 8 Unit 1B Lesson 7. Today's objective is scholars will dilate figures to create similar figures. Notice now we are not creating congruent figures the same, we are creating similar figures. So first we're going to talk about what is dilation. Dilation is enlargement or reduction. Think about your eye. The pupil of your eye dilates. It gets bigger or smaller. So the size of the figure changes. It's in proportion. So it stays the same. It's like zooming in and out. It stays the same. The shape stays the same. When we have a dilation factor less than 1, it makes it smaller. If the dilation factor is more than 1, it makes it larger. Basically, we're going to be multiplying by the dilation factor. So if it is less than 1, it gets smaller. More than 1, it gets larger. So let's look at a couple of examples here. You can see in this top example, here's our point of dilation, our center of dilation. So you see how they just sort of go out. We took each point and it gets further away. We're multiplying the points of the original figure to get the points of the new figure, the image. There we're getting bigger. You'll notice, same thing. Down here we have a dilation factor of 2. We call our dilation factor K. That means we're multiplying 2. So the point 23 becomes 4, 6. All we're doing is multiplying. The point 22, the point 11 becomes 22. The point 31 becomes 62. We multiply the points. Okay, so scale factor again is the factor a figure is dilated by. We always use a K to represent it. Factors greater than 1 get bigger. Factors less than 1 get smaller. All of your angles on your figure stay exactly the same. And the side lengths of the figure are multiplied by your dilation factor. So here, our original points of 0, 2, 2, -1, and -2, -2 are all multiplied by 2. So 0, 1 becomes 0, 4. 2, -1 becomes 4, -2. And -4, and -2, -2 becomes -4, -4. It's just multiplying. We also multiply the lengths. So the length of BC originally to the length of the image is doubled. So if this was 2, then this would be 4. So let's try it. We're going to do this one with a dilation factor of 4. So K equals 4. So the first thing we do is to write down my original points. I have V, A, and J. Right now, V is at the point 0, 1. A is at the point 1, 0. And J is at the point -1, -1. My scale factor is 4, so that's what I'm multiplying by. So 0, 1 becomes 0, 4. 1, 0 becomes 4, 0. And -1, -1 becomes -4, -4. Again, I'm just going to plot these points. 0, 4. So that's 4, 0, 0, 4. And -4, -4. So you'll notice my figure just got a lot bigger. It got bigger by a factor of 4. Not that hard. All we're doing is multiplying. Here I have a scale factor of 1/2. Remember, multiplying by 1/2 is going to make my figure smaller. So I have the points M, F, L, and W. So M is currently at 3, -2. F is at 4, -2. L is at 1, -5. And W is at 5, -5. So multiply by 1/2, and my new points are at 1.5 and -1, 2 and -1, 0.5 and -2.5, and 2.5 negative 2.5. So now I plot these points. 1.5 negative 1 is right here. That's where M goes to. F is at 2 negative 1, which is right here. So this line that was 1 is now only half. Then my next one is at 0.5 negative 2.5, which is about right here. And then my last one is at 2.5 negative 2.5, which is right here. Again, I'm going to just connect my dots. There we go. Again, the figure is smaller by a factor of 1/2. Now we're going to have a dilation factor of 1.5. Well, it's still a decimal, but it's going to get bigger. That's the first thing we need to remember. This one's going to get bigger because my scale factor is 1.5. So I start with where each of my points are, P, Z, and I. P is currently at negative 3, 1. Z is at negative 3, negative 3. And I is at negative 1, negative 3. So when I multiply by 1.5, that's going to become negative 4.5, 1.5. Negative 4.5, negative 4.5. And negative 1.5, negative 4.5. You can use Desmos if you need to multiply these. So negative 4.5, 1.5 is right here. That's my new point P. Negative 4.5, negative 4.5 is right here. That's my new Z. And negative 1.5, negative 4.5 is right here. That's my new I. So again, I'm going to connect my dots. And here's my new figure. Let's try another. Now let's think about what the scale factor is. So I started out with points K, M, and Z. Notice, am I getting bigger or smaller? First, I know I'm getting smaller, so my scale factor must be less than 1. So K started out at negative 4, 0. M started out at negative 4, negative 4. And Z started out at negative 2, negative 1. They moved to negative 2, 0, negative 1, negative 0.5, oh, sorry, this is M, negative 2, negative 2, and negative 1, negative 0.5. So in this case, it looks like I'm dividing by 2, but that is a scale factor. K is 1/2. Each of my results are half of the previous. Let's look at one more. Here, what's my scale factor? My image is getting larger. That means my scale factor must be greater than 1. So again, we look at where our points start. T, R, and S. Originally, T is at negative 1, negative 1. R is at 2, 2. And S is at 0, negative 1. And they move to, T is at negative 2, negative 2. R is at 4, 4. And the image of S is at 0, negative 2. So in this case, my scale factor, my K, must be equal to 2. Remember the big takeaways? If it gets larger, your scale factor is greater than 1. Smaller, your scale factor is less than 1. And all you're doing is multiplying your points. Okay, I will see you all in class.